Good morning, good afternoon, good evening, and welcome to my post on neutron stars. It's called Mr. Neutron, after a Monty Python sketch. Call me crazy, but I am skeptical of the existence of something as massive as the sun, but with all of the mass inside of a 20-kilometer diameter. Neutron stars are supposedly so dense that a single teaspoon would weigh 1 billion tons, and based on the pulses of light emitted from them, they supposedly spin between 0.1 and 1,000 times per second, and they have a magnetic field of between 1 and 1,000 Gauss. Of between 1 and 1 trillion Gauss, compared to the Earth's 1 Gauss. They mostly emit radio waves, but some only emit X-rays and gamma rays. With that sort of flexibility in parameter choice, they can call just about any dim object in the night sky a neutron star. If you don't know what you are looking at, just call it a neutron star and move on. Physics loves catch-alls. Just look what they did with dark matter and dark energy. And if you're paying attention to the science media today, you'll learn that our belief in dark energy may have been based on a systematic error, as in those who won a Nobel Prize for discovering it simply forgot to take the motion of the Earth into account. Ouch. Those sorts of errors haven't stopped people from producing huge amounts of colorful propaganda in support of the concept of a neutron star. It's such a strange concept that it's perfect for selling popular science books or making ridiculous movie premises. I am inclined to exercise some skepticism about the assumptions used to create the belief in strange, impossibly distant objects, because when physics gets weird, it is usually an indicator that it is wrong. I think that it is shameful for teachers to pretend that we know for certain that these things exist in the form we have inferred. How did we arrive at the idea of a neutron star? It's a really weird idea. If you look at the history books, you'd learn that we combined a simple radio wave generation mechanism with a 1934 idea from a person named Zwicky. He reasoned that if the solar systems of the cosmos mirror the structure of atoms, it would make sense that there might be free neutron stars which briefly exist after a larger solar system, like an atom, explodes. So this is basically taking ideas from the atomic realm and imagining that the cosmos works in the same way. That seems like a reasonable thing to do, but it doesn't mean that that's how reality works. Just because you can imagine something doesn't mean that it's true. That's what science is about. So what I see is that general relativity, a theory that became popular after the World Wars, and particle physics were combined to estimate the density of material which would need to be in one place for a ball of free neutrons to exist. To me, this creative bit of conjecture looks like an unholy alliance of two very speculative disciplines. If general relativity is a static approximation of a more dynamic system, I don't think it should be used in this way. If physicists had been sane, the question that should have been asked before granting a Nobel Prize for the discovery of neutron stars and enshrining the idea in the firmament is, could there have been other, less extreme arrangements of matter which could have also created pulses of light at those frequencies? Of course, but the public loves extreme stuff. It captures their imaginations, and one must capture the public's imagination in order to capture their tax dollars. If you want to see the side which lost the battle for hearts and minds, you should check out a 1968 article about neutron stars. And then note the irony of who wrote it. I have a link to it in my blog post. Kip Thorne wrote an article about neutron stars in 1968, in which he explained why neutron stars were a stupid idea. As in, before Kip Thorne sold his soul to the Gravitational Wave Observatory, LIGO, he didn't believe that neutron stars were possible because he understood that they were a result of a misapplication of theory. He understood that general relativity was an approximation and that making extrapolations from an approximation is unscientific and stupid. But this didn't stop him from building a career around writing books about black holes, neutron stars, and then helping make movies like Interstellar based on the premises that these objects actually exist. I mean, how could anybody do that? If you know it's something imaginary, yet you still sell it to the public as though it's real? I mean, what kind of person does that? Coming from an accelerator physics perspective, that's what my training was in. If I saw dim objects spewing 0.1 to 1,000 pulses of light per second in the night sky, I wouldn't immediately assume that the object which produced the pulses was ridiculously dense, oblate, and spinning at a rate of up to 1,000 times per second. I would suggest that there was a train of bunched, charged particles which were wiggling back and forth in a steady state as they traveled around a ball of hydrogen and helium, for which gravity isn't strong enough to maintain fusion. I would use the concept of a betatron tune within a synchrotron light ring to describe the pulsed physics, and I would use the concept of transition crossing to describe the instabilities which can cause stars to explode or change in their properties. I would use the concept of a radio wave laser. I would assume that gravity was lower after a star exploded, not high enough to overcome electron degeneracy pressure, as is required for the conventional descriptions of neutron stars. So, what I'm trying to say is there is an alternative explanation which isn't popular, but if you come from a different school of physics, you would describe the physics of something in the night sky in a completely different way than what is popular. And you could come up with a perfectly self-consistent story to explain it, and that there isn't just one story, as the monolithic science community today would like you to believe. I would love to see a direct comparison of the high gravity spinning neutron star concept to a weak gravity radio wave laser model of a pulsar composed of more conventional forms of matter. But who can we find to make such a detailed comparison? None of the astronomers know anything about synchrotrons, and none of the laser experts or accelerator physicists know anything about neutron stars. That's the effect of compartmentalization of physics today. The point of this post is not to convince you that I have found the one true reason for pulses of radio waves and X-rays coming from outer space. My point is that a lot of the stories we tell about objects in the sky are just that, stories. And the fact that the Nobel Prize Committee gave an award for one of these stories shouldn't sway you in the least. We should maintain our skepticism. A particle physicist looks at a spot of light in the night sky and sees the exotic forms of matter that he studies in his particle colliders, while an accelerator physicist sees the same light and sees synchrotrons. A laser expert looks up and sees lasers. A crystallography expert looks up at the stars and sees a diffraction pattern. A person who builds nuclear bombs might look at a star like Betelgeuse and see a bomb about to explode. And a person who studies bubbles might look at the same star and see a bubble that's about to pop. Summarizing, there are some weird, dim objects in the night sky that emit radio waves most of the time, often in pulses, and sometimes they emit X-rays. The diameter is estimated with the spectrum of visible light, and sometimes the mass is estimated with gravitational lensing. Astronomers call these objects neutron stars, and recently 4,600 astronomers are listed as authors on a gravitational waves paper about colliding neutron stars and LIGO, the Gravitational Wave Observatory. There are so many reasons to be skeptical of this narrative. There are weaknesses and conjectures at every chain in the narrative. It's the fact that people believe that this is truth rather than just a story is quite baffling. It shows a lot of faith in a story about a dot of light in the sky and about measurements that are probably noise. So I encourage you to look at, I've written extensively about the Gravitational Waves Observatory and the weaknesses of gravitational wave measurements. Astronomers have a tendency to make up elaborate stories to explain the characteristics of blurry blobs of light in the night sky. And imagination is great, but just because I can imagine a dragon doesn't mean that a dragon exists. Then again, maybe it is in the public interest to keep physics stupid. I mean, in World War II and World War I, we saw the destructive power of applied physics. But how this is managed at the top level and at the lower level leads to a feeling of disillusionment from those who study it. You may study this for 10 or 20 years, or some people only study it for 5 years, and then suddenly wake up and realize the weaknesses in their field of study. And you have to completely change your life at that point to realign it with something that feels more sensible and useful. So this is just my opinion, of course, but I think it might help some other people who are going through something similar in their realization about the state of human knowledge and research. And I just would like you to know that it gets easier once you realize the weaknesses in the things you've studied. It gets easier to deal with that. And that's why I wrote a novel, to try to make it, you find humor in these things. You find humor in the human condition, and it makes you feel better. It makes you feel, reconnected and like you can live your life and contribute in a positive way to humanity, which is, I think, what everybody really wants to do. Thank you for watching. Please check out my novels and my blog posts and continue watching my videos. Until next time.